All right, we're going to increase the difficulty here and mix in some other rules. And then again, it's like we're applying the derivative and then it's just kind of following the work to simplify completely. So with this one here, we could use the quotient rule, but like I said previously, I try to avoid the quotient rule if I can. So what I would do is I would go ahead and change this to 5 times and then in parentheses 2t to the 4th minus 1 cubed. Because what we have here is a constant times, and then this is a common scenario we've seen so far for our chain rule. So what I could do is apply the chain rule, and then the rule of the derivative with a constant multiplying is we just keep multiplying that constant. So what you could do is taking the derivative, that 5 will keep multiplying on, and then I'll apply my chain rule. So the derivative of something to the 3rd power, bring the 3 down, 3 minus 1 is 2, and we keep the inside function the same. Multiplied with derivative of the inside, so 2 times 4 is 8, t to the 4 minus 1, and that'll be a 0 for that negative 1 there. And then simplify. And I did the silliest thing. I left out the negative. I can't just move it to the top and have it. There we go. Okay, sorry about that. That should be an exponent of negative 3. So we have 5 times a negative 3, and then negative 3 minus 1 is a negative 4. Okay, so in the numerator, we have 5 times a negative 3 times 8. So let's see, 40 times 3, so a negative 120 t cubed all over, and I'm moving that 2t to the 4th minus 1, and now it'll have a positive 4 power with it. And we'll leave that just like that. All right, this one here, we're going to need to use the product rule. So we're going to have a mixture of product rule and chain rule. And before I apply the product rule, I'm going to change that radical into an exponent. So this is times 4x plus 1 to the 1/2 power. Okay, so our product rule said keep 1, multiply with the derivative of the other. Plus derivative of the other times keeping the other. Sorry, said the other one a lot with that, but we just want to make sure we take the derivative of 1 and multiply by the original of that second. Okay. So, taking the derivative here, what I'm going to see is right here is going to be where I apply the chain rule. So, we're going to have x to the 4th multiplying outside, that stays put. Then we're going to multiply. So, outside function is that exponent of 1/2. Inside function, I have the 4x plus 1. So derivative of the outside, bring down the 1/2, raise it to the 1/2 minus 1 power, which is a negative 1/2, keep the inside, and then we can't forget to multiply with the derivative of the inside function, which would leave us with a 4. So there's our chain rule right there. Plus derivative of x to the 4th will be a 4x cubed, and then that's multiplying with 4x plus 1 to the 1/2 power. Okay, so this will give us in the numerator 4 times, and actually what I'm seeing is the 1/2 times 4, so I'm going to go ahead and change that to a 2. So we're going to have 2x to the 4th over, and then in the denominator, a square root of 4x plus 1. Plus 4x cubed times the square root of 4x plus 1. Now, something we can do here to simplify further is create a common denominator to combine these together. So when you're looking at the answer key for the participation packet, if that final answer isn't matching up, it's because we could take steps to further simplify by combining these two terms together. So what I need is a square root of 4x plus 1 in the denominator. So for my second function here, what I'm going to do is multiply by square root of 4x plus 1, square root of 4x plus 1. So I can add these together. And this actually makes for a nice combination in the numerator, because I'll have 2x to the 4th plus 4x cubed. And now that's multiplying with a root 4x plus 1 times root 4x plus 1, which just changes to a 4x plus 1. We lose the radical completely in the numerator. And then that'll be over root 4x plus 1. And then we could simplify. So 2x to the 4th plus 16x to the 4th plus 4x cubed over root 4x plus 1. And then combine like terms for 18x to the 4th plus 4x cubed over root 4x plus 1. Now it looks nice and simplified, just like that, with a single denominator instead of two separated terms with addition. So if they're separated, try to combine them with addition or subtraction, depending on what's happening between the two terms, by creating a common denominator and combining them together. Okay, another scenario here that combines two ideas. So we have our inside function is a big one, and then outside function, that 5 there. So if I'm taking the derivative, I would take the derivative of the outside function, so that exponent of 5 drops down, inside function raised to the 5 minus 1, which is 4. Now the tricky part comes from this part where I'm taking the derivative of the inside function, which is the 2x plus 3 over 5x minus 1. And what we need right here is the quotient rule. So everything else is going to stay the same. So g prime of x is equal to, and we're going to have 5 times 2x plus 3 over 5x minus 1 to the 4th power. And we're going to multiply that with, and then we're going to use the quotient rule here, where 2x plus 3 is our high function, 5x minus 1 is our low function. So we go low d high, so 5x minus 1 times the derivative of 2x plus 3 minus high d low, so 2x plus 3 times the derivative of 5x minus 1, all over low low. So 5x minus 1 squared. And then we simplify. And something I'm going to do here, just by seeing these pieces line up, I'm going to go 5 times, actually, I'm even going to separate it. Numerator 5 times 2x plus 3 to the 4th power over 5x minus 1 to the 4th power. So I just simplified that a little bit. It's not even simplifying, I just kind of rearranged it with the exponent rules. Here we're going to have a 10x minus 2 minus 10x minus 15 over 5x minus 1 squared. Okay, more simplifying. We just keep going. So we have 5 times 2x plus 3 to the 4th power. So I'm going to do a quick mental check here. So 10x minus 2, and then 10x plus 15, but distributing the negative. Okay, we're all good there. So 10x minus 10x turns into a 0. So really we have a negative 17 multiplying on in the numerator there over 5x minus 1 to the 4th power times 5x minus 1 to the 2nd power. So to simplify it all, 5 times the negative 17, which is negative 85. We have 2x plus 3 to the 4th power over 5x minus 1 to the 6th power, combining those together. So again, we were pretty much done with taking the derivative up here. It's just then simplifying through to get a completely simplified answer at the bottom there. Okay, last example here. So we're going to have h of x is equal to f of g of x. And we know certain values, and we want to find h prime of 2. So h prime of x is going to be equal to, let's see how it works out. I'm thinking some values got entered incorrectly here, so we'll check as we go. So we're going to go f prime of, that's definitely supposed to be a 1 right there. So let's go ahead and change that to a 1. So we're going to go f prime of g of 1. So that's the derivative of our outside function, keeping the inside, except we're just going to work with x right now, times the derivative of the inside function. So there's our chain rule, and now we're going to look at this as we plug in a 1. I'm going to have one more adjustment to make, sorry. This g prime of 1 we're going to call a negative 3. All sorts of typos there. So I corrected this to a 1 and this to a negative 3 up top. Okay, f prime of g of 1 times g prime of 1. So this will be f prime of, and g of 1 is equal to a negative 3 times g prime of 1, which they, sorry, had to take a deep breath here because this example's just incorrect. Sorry, copied it from a book and shouldn't have done it because it is all sorts of messed up. We don't have enough information to answer this one. So I'm just gonna throw this on out or see if I can even adjust it to work for us here. But we definitely want to use that h prime of x equals f prime of g of x times g prime of x. Let's see if we can make this work in some form or another. And I'm just going to go with the original form here. F prime of g of 2 is equal to g prime of 2 times g prime of 2. Oof. All sorts of flustered now. Okay, so because they don't give us g of 2, that's where I'm going to go ahead and just change these to 2's so that we can use them. Okay, so this would be f prime of, and g of 2 is equal to 4 there, and then multiply that with g prime of 2, which they give us as a positive 3. So then f prime of 4, to evaluate that, f prime of negative 3 does nothing for me, so I'm going to change that to a 4, and that's where I'd bring in the 7 times 3 to get an answer of 21. Oof, that was a lot of bad copying from that problem, so sorry about that, but that's how we could do it if we had all the information that we needed.